Okay, so this is lesson 9, and you have Jamie Sigurd. Say your names.
Oh, Jesse Bollinger.
And Ruth Ramos somewhere. All right, and Jesse will start us with a prayer.
Our Heavenly Father, we're thankful for this day, and we're grateful for all the many blessings that Thou hast blessed us with. And may we ask for Thy help at this time as we are meeting together to do math, that we will be able to understand the concepts and be able to work together. And we're grateful for the opportunity we have to go to this school, and please help us all to have a great rest of our day. And we love you so very much, and we pray for these things in the name of Jesus Christ. Amen.
Okay, so should we look over the individual, or should we just go to the test quiz?
Test quiz? Are you kidding me?
Well, test.
My brain is right here on 0, so I'm not going to do it. If we could go quickly through the other that, like,
I don't know how quickly we can go through it, but we can go through it.
okay. Did you get it?
Nope. Does everyone have it up?
Uh-huh.
So do we want to go through part 1, or do we want to start at part 2?
I think, let's see.
The first 2 questions made sense to me. Beyond that, I didn't get to that.
You just, number 3, you just fill out the chart. You don't have to understand it. You just fill it out.
I don't even know what to fill it out with.
In the book, it gives you the answer.
The guy on the video had one good point that I'm going to try to have stick with me. A type 1 is rejecting the truth. If you can remember that type 1 is rejecting the truth. So he gave an example of somebody in prison. They were put away correctly. A type 1 would be that they reject that and put him away even though he was innocent. Anyways, watch that video. It kind of made sense to me after I watched that.
Okay.
Okay.
Because I certainly looked at number 3 and went, what in the heck are you asking?
Yep.
So if you fail to reject, that first box would be correct.
So that's all you're putting, is whether it's correct or not?
Yes. And then the one below it, if you reject, the what do they call it? The hypothesis, then it would be a type 1 in the column just below it. And that's where you're rejecting the truth. And then on the other 2, it's the opposite. And then it would be a type 2, and then correct on the bottom.
And you said watch the video like on top of the textbook, that first one?
No, at the very bottom where he works through the problems, he'll give you a better understanding of what it's talking about. It's still not totally clear in my head, but that's where I got some understanding of it.
Okay, number 4, to find the level of significance in a hypothesis test. With which Greek letter is it denoted?
It's A, no?
Yeah.
I just remembered 'cause I just read that. A.
So, and this had to do with the 0.01, 0.05, 0.10. And that's got to do with the chance of making a type 1. On there. Okay, we'll read it. But it's got to do with type 1.
At this week, I feel like at this point, I feel like I just walked into a German class with no experience with German, and it's halfway through the semester, and I'm lost. Completely foreign language.
You'll find yourself.
How'd you do on the test, Jamie?
As expected. I don't know about the score I deserved, I think. I didn't fail. That's a good thing.
That's good. That's good.
So, in other words, you rejected the hypothesis then, huh?
Probably. I don't know.
There's our example. It means you were down on the bottom half of the expected mean.
Probably so.
That's all right. That wasn't too bad.
Do you remember what sigma is?
6?
Sigma? Because in the next number 5, write down the formula for computing the test statistics for the hypothesis test for a single mean when sigma is known. What is sigma?
Oh, it's cheap. What is the symbol for sigma?
Siri could join us.
It is the formula is that Z formula where we have the
sample?
Where we're dividing by the square root of sample size.
Okay, that's what they're referring to?
Yes.
Okay.
So yeah, it's the sigma sign is the standard deviation.
Okay. Gotcha.
So did you guys, the other two of you, remember that formula?
Mm-hmm.
We're looking at 5?
Yeah.
So 6 is just to find the p-value.
Yep.
So the book just says probability of obtaining a sample mean or test statistic at least as extreme as the one calculated.
Yep.
So that's basically finding your p on the outside.
Yeah.
Okay. Number 7. If the null hypothesis is rejected in a hypothesis test, what is concluded about the alternative hypothesis? If a null hypothesis is rejected.
So that would be on the second one over there. You rejected it. So it would be correct. It would be true.
If we are
Referring to the chart.
Yeah. But you got it's either going to be one or the other.
right, so I'm still I'm okay.
So if you rejected the hypothesis, then the alternative is going to be true.
So number 8, think of a couple of examples where you have seen hypothesis testing in real life. Is this where we talk about the test?
The part 2 comes up after this. This is the last one on the 2 I used. I had the hypothesis was $350,000 appraised house, and the alternative was the mean was less than 350 on the sale price. So I actually sold it for less than it was appraising for.
So would it just kind of vary, like depending on?
Yeah, it could be. You could go. There's 3 different ways. So you're either a 2-sided would be you're looking for left or right, doesn't really matter. Could be higher, could be lower. Basically put it in that symmetrical shape and make it true. Or you'd be a 1-sided, skewed or right skewed. So it's greater than or less than. Right, and that's really all it's asking you. So come up with scenarios in your life where you've seen that.
Should we start the part 2?
Sure, let's go for it.
I'm not ready for it, but let's do. Got to do it. I think it's good practice before our exam or quiz. I mean.
No more exams.
Damn, it's just a quiz.
It's a quiz. It's a quiz. Sorry.
It doesn't have like 40 questions on it.
Yeah, I think maybe let's just jump to the quiz though, because we can work out those problems on the quiz just as we would on this. So. I don't know. That's my opinion.
How about we try one?
Okay.
Honestly, I haven't even tried any. So this is my first attempt to try to figure one out. So
I just feel bad because I feel like Jeff has done all the work and we're just the peasants over here.
Whatever. I got up this morning and did it early. That's why.
Because you're committed. We probably could have done that too. I don't know.
Well, I'm committed to making sure I meet the goals that I have for my family. Yes, you are right. But that was the only reason.
Okay, well, should we do 9? then?
yeah, let's do 9.
Okay. The graduate management admission test, the GMAT, is used as an admission criterion in many Masters of Business Administration programs. The scores on the GMAT in the past have a mean score of 529. The BYU professor feels now that the score has improved within the last couple of years. Determine the null and alternative hypothesis.
So the mean, determine the null. Oh, wow. Forget the mean.
No, no, you're looking for the mean. So it would be HO would be the null equals the mean of, and that's what you're looking for.
Of the 529?
That is it.
So HO is equal to 529. And HA is not equal to 529?
It's not. And so what's it asking though?
Well, it feels like they've improved, which means it would be N, or the variable is greater than 529.
Yes.
Oh, beautiful. Okay.
What?
So you
what
would write
variable
that.
use?
So you would write that HI semicolon mean equal to, or mean greater than 529. So it would be the HA semicolon, the symbol for the mean greater than 529.
Okay. Suppose you got evidence that the null hypothesis should be rejected. However, in reality, the mean score of students taking the exam is still 529. Was a type 1 or type 2 error committed?
Remember what I told you earlier, type 1 is rejecting the truth. So they said it was greater than 529, so they were rejecting what the truth was. So
Okay.
type 1.
If the analysis was done at 0.01 level, what is the probability of committing a type 1 error?
I'm sorry, I missed you with the B, on B. Suppose you got evidence that the null hypothesis should be rejected. Suppose you got evidence that the null should be rejected. However, in reality, the mean score of students taking the exam is still 529.
So they rejected the null, but it was true.
You rejected it,
So
but
I told you, that's why I told you on that first page, type 1 is rejecting the truth. So they actually rejected the truth.
okay, I understand that. Yes. So that would be type 1. I understand that. Okay, I'm sorry. Go on. Number C, sorry.
So on C as well, committing a type 1 error because it
They're just asking what's
mean that
the chances of it.
It's a smaller number than.
It's actually dumb. This question's stupid. The answer is 1%. That's your probability of making an error is what they give you right there at 1%.
so that's saying that the score varies 0.01 from the predicted mean.
Yes.
Okay. Okay, easy enough. So if we wanted to decrease the probability of making a type 2 error, would we need to increase or decrease the level of significance?
Increase.
Increase those, right?
I got that part, but I didn't get the C part.
So the way he described that is if one's going to go up, the other one's going to go down.
Right, I got the decrease. But this number C, where it says if the analysis was done at the significance level of 0.1, what is the probability of committing a type 1 error? That's where I'm stuck. I got the next one, which makes sense. 0.1 meaning that it's a really low level.
Right. Right. So the chances of making an error are very slim.
Okay.
Okay, should we do 10 or should we go to the quiz?
Whatever you guys vote, I'm not going to be much help. I'm still trying to figure it out.
10 kind of helps you use it in the the QQ plot and the histogram. It has you making those. So I don't know if you want to do that on your own. That might take a few minutes, but we can pull it up whatever you want. I don't know how much longer you have, Jamie. So
maybe we should go with the quiz. I don't know. How are you, Jesse?
Under the quiz.
I mean, it's basically just walking you through what we've already done 2 weeks, just using the terminology. So.
Well, I don't care. We can do either. Maybe let's just.
Let me pull it up real quick. Let's see what it looks like.
Has lots of parts to it.
That's not what I wanted to hear.
Like literally half the assignment.
Jamie, you're supposed to bear better news than that.
There's 21 questions.
Oh, yuck.
On the quiz?
Yeah.
No, let's just do the quiz then.
Do not run until calculation is complete. Which hypothesis involves equality?
Would it be the null?
I don't remember hearing the word true hypothesis. Above 4, the p-value is the probability of obtaining a sample statistic at least as extreme as the one that was actually observed. Use this information to answer the next question. Remember that the p-value is the probability of obtaining a sample statistic at least as extreme as the one that was actually observed. When computing the p-value, which hypothesis do you assume to be true?
I'm sorry, where are you guys?
Number 4.
Number 3 is the alternative hypothesis.
About the null.
No. The reason why is because I have a little note here that says alternative hypothesis.
Alternatives are greater or less than.
And equal. No?
No.
No. Equal to is a two-sided. I could be wrong. I'm going with the. But alternatives would go away from. Oh, what do we go?
You're right. I found it. You're right. Sorry. I found it.
Need to find nothing to be sorry about.
Okay. So
P-value, I'm not positive on that one. I would say alternative, but
remember that the p-value is the probability of obtaining.
you probably got that pulled up, and I'm trying to pull it up. So
To be true. The null, right?
Yeah. So right here it says the p-value is the probability of obtaining a test statistic at least as extreme as the one you calculated, assuming the null hypothesis is true.
okay.
So it is null hypothesis, right?
Okay, because that's what you're figuring, the null hypothesis. Okay. All right, I got that.
I can read question 5 if we're ready.
Yeah.
Ready?
Suppose the null hypothesis is HO mean equals 10. Use this information to answer the next 3 questions. Which of the following represents the alternative hypothesis for a two-tailed test? Is it the second one, B, whatever?
Third one.
The third one?
Yeah.
Two tails.
So with the equal with the slash through it, not equal to 10?
Wait, which one of the following represents the alternative hypothesis for a two-tailed test? Yeah, two-tailed would be
The third one.
you're not equal to, it's the third one.
Oh, okay.
The second one would be alternative. The first one would be alternative.
And
And
what would,
the fourth one is exactly what they gave us, so I don't know what the, that one doesn't have anything to do with anything.
so, we ready for 7?
Yeah,
Wait, did we do 6?
no, 6, we gotta do.
Oh yeah, sorry. Okay.
So to the left would be what?
That would be the first one, right?
Yes.
Guys.
What's that?
So then for 7, when it's a right tail test, then it's the second one.
Yeah, just
Yes.
opposite.
Mhm. Should we move on?
Yeah. Or remember that we determined the outcome of a hypothesis test by comparing the p-value to the level of significance, or A, which relationship would result in failing to reject the hypothesis.
It failed.
Is this referring to the graph at all, the table, or no? Maybe not. Never mind.
Which one are you talking about? The
8.
applet?
No, just the table and the preparation. No.
Oh, I don't think so.
Okay.
Which relationship would result in failing to reject the null hypothesis? P-value maybe. I think it's the first one.
The first one?
When we fail to reject it when the p-value is large. So
So that would be,
A, the first one.
yeah, that's what I think.
Okay.
And the next one is which relationship would result in rejecting the null hypothesis.
That should be
Reject
B, right?
Rejecting. Yes.
I'm gonna read the next one.
I'm not, does someone have that pulled up? I just want to make sure it's not less than the Z-score. I'm pretty sure it's B, but
So if A equals 0, no matter what test we do, no matter what the data show, we always fail to reject the null hypothesis.
You said it's greater than 0?
If A equals 0.
Where are we at, guys?
Just double checking 9.
Oh, if you look at the chart on the book, there's a chart there on 4.32. There's a chart of bell curves. And then the bottom chart says large p-value, you fail to reject it. And then the other one says small p-value, you reject it.
Oh, yeah.
Yeah.
Okay. I thought it was right. I just wanted to make sure. Sorry.
Yeah, that's
It was
fine.
the one thing that I didn't totally grab a hold of.
Yeah. Okay, Jesse, I'm gonna read that one.
Okay. An insurance company is reviewing its current policy rates. When originally setting the rates, they believed that the average claim was about $1,500. They were concerned that the true mean is actually higher than this. Use the information for the next 2 questions. So which of the following would be the appropriate alternative hypothesis?
The average claim amount is greater than 1,500.
Mm-hmm.
That's what I thought.
Which claim is
So it's going higher.
lower? So what are we? Isn't it the average claim? Okay, so the null would be that the claim is 1,500. That's what the true mean is.
Correct.
And so then higher, the true mean is actually higher.
So that would be HA semicolon mean greater than 1,500.
Why greater?
Because it says higher than.
Oh, okay.
So 11 is similar, but it's the appropriate null hypothesis, which we were talking about. So wouldn't it be the first one? The average claim amount is equal to 1,500.
Yeah, that's what I think.
I guess. So is that what we're going for?
Yeah.
Okay.
I think that's really only asking for the top portion of, because every one of them you got to have 2. Only the top portion of it. So.
Okay, Jeff, do you want to pick up 12?
Yeah. The insurance company randomly selects sample 40 claims and calculates a sample mean of 1,650 using information that's answered the next 3 questions. The insurance company assumes the distribution of the sample mean is normal. Is this a good assumption? was it before?
Yes. Number 1, wouldn't it be number 1? It is a good assumption since the sample size is large.
Probably. Yeah.
It could be, well, it would be normal even smaller though, as well, because the distribution is normal in the first place. So it could be, it is a good assumption since the population is normal.
That's true.
But then again, it is large, which makes it normal, more normal. I don't know.
Well,
I almost think it's a good one though because it's normal, because that's the first factor that plays into it.
I don't know where, if you're just taking the information that's shown there. Oh, yeah, I see. Question is answered. The insurance company assumes the distribution of sample mean is normal. So it's assuming it's normal.
Okay.
Yeah, I was gonna say when.
And I would say that they're assuming it because it has a large sample size.
Okay. Yeah, that makes sense.
I don't know. I could be reading too much into it, but
So you're feeling
there's not
better
much
about the
information.
first one.
Yeah.
Well, reading it like with the question then the answer, so assumes the distribution of the sample mean is normal. It's a good assumption since the population is normal. Well, that's, I don't know, it just sounds funny to me.
Kind of repeating what you said, yeah.
I've been known to do that on some of these stupid questions. So.
True.
Go with the sample size because that's a number that shows.
Okay. Well, I think I'll go with that one as well.
Because they're just assuming it's going to be normal because we do have a large sample size. It didn't say that it was normal, because then that would tell us that it had a bell curve. They're just assuming that it is because it has the large numbers that it'll be that way. That's the way I'm reading it. So.
Okay, 13. What theorem or law justifies your answer to the previous question? Law of large numbers?
Or central limit theorem.
What the heck is the law of total probability?
A distractor.
Okay.
And that's exactly what it's doing.
Yeah, the wonderful way we take tests. They love to put distractors in there, see a question.
Would it be the central limit?
Yeah,
I think wouldn't it be the large numbers?
Well, when you're looking at the definitions, so central limit is guarantees that the sampling distribution of the sample mean will be normal if the sample size is large, or law of large numbers. When the sample size is large, the mean will be close to the population mean.
Yeah.
Oh yeah. So the central limit theorem is talking more about the distribution. And where the bell curve is at.
Yeah, so wouldn't it be central?
Yeah. Sometimes those are super clear to me, and other times I completely forget everything about them.
I just remember the central limit theorem, or whatever the central limit theorem is based on the shape, based on the mean being getting smaller and drawing in towards the mean. So the law of large numbers would actually drop the standard deviation. That's kind of the way I've tried to remember it. So this one to me is dealing more with the shape. So I think it is a central.
Yeah.
Because the sample size is large, but it's not that large.
Okay, going.
Yeah.
Which of the following is the test statistic as defined in this lesson? Is it Z?
A sample mean, so would it be N? That should be easily found. Then. The test statistic, so that should be the sample mean. No, so the mean would be. That would be your X. Is that what you said?
So the first one?
Is that what you said, Jamie?
No, I said Z. I'm just looking at the textbook and trying to put it together.
Yeah, so that would be the sample mean minus the mean.
Did you find it, Jamie, in the book?
Yeah, on 4.2 it talks about the test statistic.
Okay.
Yeah, it's the X.
Okay.
Right.
For the first one.
The sample mean is X.
Okay, yeah. Okay, if we're good to keep going, Ruth, do you want to take 15?
Okay. Since okay, so I'm sorry, I'm going back to the same question we just did.
No,
So
it's Z.
So it's Z?
And that's in that 4.2.
Yeah, I'm looking
So
at it. That's what I was about to say.
Where Z is the test statistic, X is the sample mean. Really confusing the heck out of me, man.
It says, since we know that the deviation in this case, we can use Z-score to determine if X
Okay, that's what it
is far from, this is called a statistic. Z is a, okay, I see it.
Yeah, it's Z.
Sorry, I see it.
So
Okay,
Jamie was right.
yeah, she's right.
Good job, Amy.
Job. Okay, so the historical mean of sales receipts at a grocery store is 150 with standard deviation of 40. The store manager suspects that the average has decreased. He sets up a hypothesis test with the hypothesis. She will use a level of significance of A equals 0.05. She then thinks a simple random sample takes a simple random sample of 36 sales receipts from her store and computes X is equal to 144. Use the next information to answer the next 4 questions. What is the Z-score associated with this test? Round to the nearest 3 decimals.
So is this set up like normal, like what we did before? When things made sense.
This is that Z-score with the sample, right? Sample mean.
So 144 minus 150 over the standard deviation. So negative 0.15.
What'd you say the Z-score was?
I got negative 0.15.
That's what I got too.
X is 150.
X would be 144.
Oh, I got it backwards. Okay.
So random sample is 36.
I got negative 0.9.
Say it again.
Negative 0.9.
That's what I got. Because it's a negative 6, and then the square root of 36 is 6.
Okay. That's right.
6 into 40. Should give you a 6.66686.
Which makes more sense too because it says round to the third.
Wait, so what would be N?
N is your 36 samples.
Oh.
So what is
So then,
Negative 0.9. That's what you got.
Yeah.
Okay.
Negative 0.9?
yeah.
Okay. That bugs me though that they put round to 3 decimal places because that makes me second guess. Whatever.
I just tricked it by putting 2 more zeros.
Ruth made herself feel good.
Okay, what is the p-value associated with the z-score from the previous question?
That's where we have to put it in the applet, no? Yeah.
But-
Put the
That's-
z-score in the applet.
Does the applet determine the p-value?
Yes, or at least that's what I understood,
No.
Jeff. No?
The p-value would be the percentage at the top, if I'm remembering correct.
Of the area.
Because of what you have highlighted. So
So we just have to make sure we highlight the right thing.
yes, she will use the level of significance 0.05. She then takes a random sample of 36 receipts.
How do we know if it's two-sided, one-sided? Uh-oh.
Well, they're looking for less than 150, so it'd be left side. Up in the original question.
In the original question, it says left?
Well, in the information,
Uh-huh. She will lose a level.
it says that the alternative is less than 150, so it's going to be highlighting the left side.
I see. I see.
So 0.1841.
Yeah, let's look up p-value really quick, but p-value is the area in the tails beyond, so the area is yeah, so you're looking for the probability of getting less than that, at least as the extreme. So the p-value is the probability that would get the z-score, so it is the top.
Okay, 184.
So it's 0.184.
Okay, someone pick up 17.
I get it.
What
inference?
Oh, sorry.
Go ahead, Ruth.
What inference would you make about the null hypothesis for this problem?
Reject the null hypothesis.
Fail to reject? No. Okay, let's start again. Why do you say, Jamie? What inference would you make about this?
Well, the null hypothesis is 150, and the sales receipts calculated the mean to be 140 or 144. So that's obviously not the null hypothesis. So I don't know. I guess that's my reasoning from what little I know.
But I think it has to do with the 0.05.
And the 0.184?
Yes, that's how you're going to figure to answer this. If the p-value is small, that implies the z-score was very large. In other words, x was far from you. In this case, your z-score is 6.6 below the mean. This is usual. That applies. I think it's so what was it? 0.9 is greater than the 0.05.
Why are you basing yourself on the z-score?
Let's see.
Oh, man.
Okay, here we go,
All right.
4.4.
So right here it says the level of significance is the standard for determining whether or not the null hypothesis should be rejected. Typical values for A are 0.05, 0.10, and 0.01. If the p-value is less than A, we reject the null. If the p-value is not less than A, we fail to reject the null.
So we need to fail to reject.
Because it's 0.05. Wait.
If the p is low.
So the p is the area of the probability up there, and it's 0.18. So if you look at it, it's not a very outlying. If that z-score was like 2 point something or whatever, it would take it out and the area would get smaller.
So you said fail to reject the null?
Yeah.
Okay.
Because I think it also, if you go in there and look at it, the 144 falls within the standard deviation.
If you look at the 4.4 level of significance on the book, doesn't it says right there in a box, it says if the p is low, reject the null.
Yeah, and the p is not low.
Okay, so what's considered low again? Is that A is equal to 0.05? Is that the measuring?
Yes. So if it was less than that, then you would reject null.
Okay.
But since it's more than that, we fail to reject it.
Okay, I understand. Wow.
Okay, so what is our conclusion for this problem? We have sufficient evidence that the true population mean is less than 150.
Well, we failed to reject the null.
That's true.
So would be the second one.
I have no clue.
Yeah, I think I'm going to put the second one. I mean, based on what we've put, we failed to reject it. So.
So you would say the second, according to what
That's
we
what I'm
wrote?
putting. That's what I'm putting. I don't expect you to agree with it.
Well, it goes with what we actually wrote.
Right. Because you can sample 40 people. He does talk about that, and you could get 40 of the lowest receipts, but that doesn't mean that it changes the mean. It still falls within that probability. Because those receipts aren't really low. Remember, the standard deviation was $40, so that would take it down to 110 or up to 190. That's what would fall within the center section there.
Oh, I'm gonna fail this one.
Okay. Well, let's keep going unless there's any questions.
Okay.
Question 19. There are two types of errors that can be made when performing the hypothesis test. Which one involves rejecting the null hypothesis and the null hypothesis is true?
Is it type 1?
That's the definition that I gave you for that. So, rejecting the hypothesis even though it's true. We'll get one right, Ruth.
Wait a minute. Only because you guys are telling me this, there are two types of errors that can be made with performing a hypothesis test. Which one involves rejecting the null?
So it's just referring to the table, right?
Yeah.
The table that we wrote. Okay, let me look at it.
Yeah, type 1 is rejecting it even though it's true.
Okay, I see. Okay, yep. I'm good.
A researcher decided that instead of using a level of significance equal to 0.05, he will use a level of significance of 0.01. Which of the following would be true? I think it's 2. Researcher decided. Error, so we choose a very small value. We choose A to be small. That would happen as probabilities. So it's right down there in 5, below the table. It says we do not want to commit type 1 errors, so why not choose a very small value? If we choose A to be so small that we rarely commit type 1 errors, what would happen to the probability of committing a type 2 error? Think about it. If type 1 error is very small, the probability of committing a type 2 error will be large. Conversely, if A is allowed to be very large, then the probability of committing a type 2 error will be very small. So they're opposites. So that's a 1% chance of being wrong.
So it's more probable that they will be right.
Yeah, so committing a type 1 error with that would be almost impossible. So the probability of a type 2 area increases when we drop that.
Okay.
So it would be the probability of type 2 error will increase.
Yes.
Where did you read that again?
4.5 underneath the table.
Okay. 4.5.
Hey, we made it to the last question.
Yep.
If A
is equal to 0.05, compute the probability of committing a type 1 error.
Wouldn't it be wouldn't it be 5?
round to 2 decimals. Didn't say given to percent. I mean, if the answer is what it is,
Yeah.
you have a 5% chance. So I'm thinking it's just 0.05.
Dumb.
What?
Yeah. It's the same as a question they asked on the practice.
The last 2 questions? Okay.
Too good to be true.
Compute the probability of committing a...
So in 9C, on our practice stuff, if an analysis was done at 0.01 level, what is the probability of committing a type 1 error?
And it's 0.01. Yeah.
Or 0.01. So it's just a question.
Okay, should we submit?
Yeah, we'll see how good it is. Any worse than we did last week on that one.
Let's not too soon.
Hey,
Whatever.
22 out of 23.
So the last answer was 0.05, right?
Yep.
Okay.
Good
We
job,
missed.
guys. We missed number
2.
18.
What was your conclusion for this problem?
I wonder if it's we have insufficient evidence. So we're not disregarding that it may be 150, but we don't have enough evidence to really determine that at this point. That would probably
Number 12 is not a good assumption since the sample size is. What did you put? Wrong one. That was good, you dummy.
I hate when that happens.
Yeah, I know. It's one we talked about. So 12 was A, right?
Mm-hmm.
Yeah, and I hit the stupid sample size is small. That was beautiful.
That's happened to me more than once.
You only had the one that you missed?
Yeah.
Yeah.
Yeah, and I had the 2. So.
Okay. Well, overall, I would say that was pretty good.
Nice job.
Yeah. Thank you, Jeff, for all your help.
Yes, thanks, Jeff.
We're
I
prepared.
would bring cookies to our next meeting to thank you, but that won't work. So get some cookies on your own.
You know how that works. I thank you guys because the opportunity to share other things helped you even learn more. So
that is true. Yep.
I
Okay, so
gained as much as you did.
actually, let me end the broadcast.